Yeah, what's up, Noise? Still got your fountain pen. Still using it. Still using it. I just love that I have like unlimited gold ink, you know? It's the best. Like I'm never gonna run out of gold ink because I got this massive container of it.
Of course.
Yeah.
Brilliant.
I used to always buy those like those gold like gel pens and whatnot, but they were like $3 and they would dry out and stuff. But like now I just have unlimited gold pens. I'm like dope.
That's dope.
Tasty.
Hello.
What's up, Ethan?
I'm doing good.
Good. Nice.
I just got 5 merits.
You got what?
5 merits.
What are 5 merits? Is it like demerits? What are
Like,
5
basically,
merits?
It's like when you do good deeds consecutively.
Oh, nice. Kind of like bond coins here. Kind of like bond coins, basically.
But it's something where you do that's good. Like that either contribute to someone or maybe there's some.
And what, your school
some
gives
other
it to you?
teacher, like,
Does your school give it to you? Is that what happens?
well, the teacher that gives you the merit will give it to you.
Oh, okay. And what do you do with the merits? I mean, that's
Then-
dope. But like, what do you do with them? I'm curious.
You basically give it to like the vice headmaster or the vice principal.
Uh-huh. What, does he buy you an ice cream or something? What happens?
And what kind of similar? It's like buy you a sweet or a chocolate. So yeah.
Oh, chocolate! We do love some chocolate.
I just got my 5th one today.
Sick, dude. What did you do? What did you do that got you a merit, dude? Why did you get a merit? Explain to us.
No, it's 5 merits, okay?
How did you get 5 merits? What'd you do?
So, there was only one that was so different from the others. Or, like, I think it was just, so see, I did one for like, I got 3 merits for like sweeping a home teacher's class.
You like took a broom and like you sweep the floors?
That's what
Oh,
I'm
that's
saying.
really nice of you, dude. Wow. I wouldn't like ever think to
And a
do that.
teacher- And then next thing is like, there was one teacher who gave me 2 merits for that, for kindness and initiative.
Yeah, taking the initiative doing things, which is something you're very good at, Ethan, honestly. You're very good at like taking the initiative doing things, which is cool. And honestly, it's a rare characteristic for people to have, so yeah, keep that shit up.
And then I got the other 2 because of drawings of her teachers.
Oh, you did some drawings? That's cool. Yeah, people like artwork.
Yeah. And yeah, see the 5th one was from a teacher who had kids, and I drew them.
Drew all their kids? That's sick.
Mm-hmm.
Nice,
like,
dude.
Like drew all the kids something. I care.
Oh, you draw something for their kids. Oh, that's really cool.
Mhm.
What is Echo Chaos saying here, dude? Echo says, "Thank you. Help me with history homework." Yes. What do you need help with history homework? I mean, I'm always curious. Like, history to me is just like writing a bunch of papers. Which I can kind of help with. Do you have a screenshot of it? Give a screenshot of it. You can. What's up, Ethan?
So I've been wondering, since I don't have a question today, could you help me make one?
Yes. Yes, let me get through everyone else's questions first, and if I have time, I'll make one for you. How do you know humanity won't die because it's 23 minutes? Okay, alright, chill people. Okay. Alright, yes, we'll get to it. I need to join the Discord, really, because I got a new phone. Could you send me the link? Yeah, here's the link, dude. Or you can always just do, I think this works. Yeah, just do exclamation Discord. There's a Discord. Yeah, all good. How are you deafened? I'm server deafened? Who deafened you? What? I don't know how to I mean, I can mute you. I can unmute you. I'm server deafened. I can't turn off your deafening, unfortunately, Jamarcus. That's on your side. Like, if I could undeafen people, that would be kind of dangerous, right? If I could just, like, randomly go up to people's Discords and be like, you will listen to me. Okay, now you're a speaker. There you go.
I turned it off. It's fine.
Oh, thank you. Wait. You can turn him. You can turn off his undeafen, really? Oh, I guess I see
Yeah.
server deafen. I see that. And server mute.
That's what it was. That's what it
Oh.
was. He was
Why-
server deafened.
Who the fuck server deafened him?
I have no idea.
What? God damn it. I mean, I can go through the audit log and find out who did it, but I don't know. Oh, you did. Oh, he deafened himself. Okay. All right. That's interesting. Okay. All right, cool. Here, let's start off the stream. We got some cool stuff going on. All right. Welcome, everyone, to Office Hours. My name is Dr. Gold with Actual Education, stream that helps you out with math homework, science homework, maybe even some history homework today. I haven't helped someone with history homework in a while. Yeah, it's Monday. Did you guys have a good weekend? Noise, did you do anything fun this weekend? What'd you do?
Nothing.
Nothing.
No.
I almost had like too much
Square
fun.
root of fuck all.
Square root of fuck all? Wait, but she doesn't know that. She doesn't know what the square root of fuck all is, right?
No.
No. Uh-oh. What was I doing? Where did I go? Oh yeah, I did some fun things this weekend. Let me hear. Here, I'll post them for you guys. Let's see. I started finally washing some of my Burning Man clothes. The gold stuff that I can't put in the washing machine. I had to like clean it in my tub. And like look at all this like dirt that's coming out of it. I was just like, this is gross. So yeah, I had a bunch of that. What else did I do? I went to a Royksop concert. Anyone heard of Royksop? Royksop's mad proper. I love Royksop. They are, I think they're Norwegian, is what they are. But it was a very cool concert. I went with some friends and saw them. But then I ended up going to like a Burning Man after party somewhere. It was my buddy's warehouse in LA. And that ended up going to like 7 a.m. So that's why I apologize I wasn't able to do Jackbox on Saturday. I told you guys that, like, yeah. I said no guarantees on Jackbox. If I'm out till late on then I won't be able to do it. Yeah. It was cool though. It was cool. Good people. What else did I do? Oh, I'm a big sandwich guy. I don't know if you guys like sandwiches, but I made this sandwich as well. I thought it was a really nice sandwich. But yeah, little meatball, little cheese, some marinara. Yeah. Okay, that was kind of my weekend. So that's the square root of sandwich, I guess. Oh, and then my friend A-Rod had like a little like mini barbecue for us. And you've seen him before. He plays with us. Yeah, same, right? Yeah. Yeah, we had like a little barbecue. Oh, this dog's hungry. He wants to eat some of our food. Yes. Okay, cool. All right. That's it. Okay, that was my weekend. Cool. I was trying to watch Noise's stream, but the volume wouldn't mute. Oh, interesting. That's weird. Okay. All right, here. Let's go through the first questions of the day. And then, is Titan Lord here? I meant to get to Titan Lord's question yesterday, but we ran out of time. Because, again, I had to go to that concert. That's why I had to run. I had to go to that concert I was at. If Titan Lord's not here, I think the next person is Teacup. Teacup, where you at? You hear Teacup? Is Titan Lord your friend, Jamarcus? Do you guys know each other from school? I know that a bunch of you guys like invited each other from school. Yeah, right? Okay, that's cool. Okay. Hopefully Teacup survived. I think there was a big tropical storm or something. Is there a tropical storm that happened? With government shutdown, troops still protect nation but without any pay. Okay, whatever. There's always something going down. What was it? Tropical storm, Florida. What's happening? Oh, Philip. I guess Philip was the one. Oh, but now there's another tropical cyclone. I don't know. Florida's like not a good place to live around these months because there's a lot of stuff happening. Okay. Well, whenever Teacup wants to show up, he can show up. Is this you, Tuhi? Is this your question? It's kind of a fun one. Yes. Okay, cool. All right. What grade are you in, Tuhi? I think this is fairly simple. You should know how to do this stuff. We're good friends, I think, I hope. Yes, you guys are good friends. Chill, Jamarcus. Sorry, I had Defen on Discord. Oh, it's okay. You're back. All right, that's awesome. Okay, cool. Yeah, these are good questions. This is just dividing stuff, right? You guys should know how to do this stuff, right? What's negative 30 divided by 10? I know you know how to do this. I'm gonna give you something harder, but I want to make sure you can do this first. What's up, Kiss Killer? Yeah. Yeah, negative 30 divided by 10. Right, good. It's negative 3. Wow. Congratulations. What's up, Kiss? Yeah, what's up, Kiss Killer? What's up, guys? Yeah, this is very easy. Okay, cool. What grade are you in, Tuhi? What grade? What grade? Like, what grade of math? So I can know, like, what to give you. He's in 8th grade? Okay, cool. All right, you should know how to do stuff. All right, we're going to do this. All right. You're in grade 8. Awesome. That's cool. Right, these are just dividing negative numbers and whatnot. I'm very sure you know how to do this. Let's say we do something a little bit trickier. Let's say, for instance, I have negative. What do I want to do? Let's do negative 3/4 plus 2/3, for instance. Do you know how to do this, Tuhi? Do you know how to add two fractions where one of them is negative? It's a good question. Not one of the negatives. You know how to add fractions. Okay, that's cool. We'll show you. They're kind of the same. So how would I add these fractions together? How would I do that, Tuhi? Thanks, Echo. Yeah, I'll check your screenshot. Same denominator. Good. So what is going to be the same denominator for these two things? What can I get to get the same denominator? 12. Good. Yes. That's called like the least common multiple is what that's called, LCM. You can always find a common multiple by just multiplying these two things together, but sometimes that's not the best one. So for instance, if I had like 1/2 and I don't know, like 1/4, right? You'd be like, oh, if I multiply this together, right, that's 8. But in reality, you could just multiply this by 2/2 and get 2/4 plus 1/4. And now these technically have the same denominator as well. So yeah, a good default is to multiply the two denominators together, but if you're clever, you can sometimes notice that they maybe hit the same number. Okay, so Tui, what do I do? What's done to bottom, you do to top, correct? Yes, Echo. Very, very correct. Yes. That's the rules of math. Whatever you do to the bottom, you have to do to the top. And the reason for that is that it doesn't change the number. So for instance, if I were to say, let's multiply, it goes for the top. Yeah, so here, let's show why that is. Okay, so Tuhi, what am I going to do to each one of these numbers if I'm trying to make them have the same common denominator? Yeah, they're common multiple, LCM. Yep. You found it. 12 is it. You can also do this manually. You could do like 4, 8, 12, right? And here this would be like 3, 6, 9, 12. And you're like, oh, look, these numbers match. So that's an LCM. That's another way to do it. Yeah, we found the LCM. So what do we do with the LCM now that we know it? What's the next step? We multiply the denominators, yeah? And both of them should be 12. Okay. Yeah, good. Yeah, I want to try to make these denominators equal to 12. So what am I going to do? Good. 4 times 3. Yeah, that's okay. That's what Discord does. Yeah, Discord does that when you put a... If you put an asterisk, it italicizes things. Yeah, you're good. Good. 4 times 3 is 12. Good. And 2 times 4 is 12? No. 3 times 4 is 12. Yeah, good. Okay. All right. So, what I'm going to take with this one right here is I'm going to multiply both the top and the bottom by 3. And the reason why this is okay is because if you multiply the top by 3 and you multiply the bottom by 3, you're basically multiplying the whole thing by 3 over 3. And do you guys know what 3 over 3 is? What's that? What's that the same thing as? 1. Good. Yes, good. This is technically called the multiplicative inverse, is what it is. Yes, Jamarcus, right? Yeah. This is the multiplicative inverse, yeah. So, multiplicative identity. That's what I meant to say. Multiplicative identity. And it's called the identity because if I multiply this by the multiplicative identity, it doesn't change the number, right? Multiplying by 1 doesn't do anything. 5 times 1 is still 1. You know, 69 times 1 is still 69, you know? That's how it works. So good. Yeah, we're going to multiply this by 3 over 3. And I'll multiply this side by 4 over 4. Okay. And let's see what we get. Yippee! I know, this is fun. You know, math is fun when you're just like getting shit like constantly. You're just like, oh, it's so easy. I love it. Yeah. It's honestly, when it gets difficult, it's kind of demoralizing. So this becomes negative 9 over 12. And then this becomes plus 8 over 12. Oh, yeah, sorry. 5 times 1 is equal to 5. Yeah, my bad. It's Monday. I'm like kind of slipping on some of my typos. We hate Mondays, yeah. Also, I didn't have my coffee today. My coffee mug is empty. I meant to make coffee this morning, but I got slammed with a bunch of emails of people being like, oh, can you fix this? Can you fix this? And I was like, ugh, damn it. I don't have time to make coffee. You have a class thing today. Okay. When are your hard questions coming out, Jamarcus? We want the hard questions. Okay, Tuhi, what do I do next here? I have negative 9 over 12 plus 8 over 12. What are we going to do? We add them. What do we add? Good, yes, we add the negative 9. Negative 9 plus 8. What do we do at the bottom here? What do we do with the bottom numbers? Stays the same. Yep, good. This is called like combining. We're combining two fractions now because they have the same denominator. Okay, almost done. Last step. What do we do here? Negative 9 and positive 8. What's that? Answer is negative 1 over 12. Yes, you're correct. Good job. Nice.
Nice.
Good job, Tuhi. Yeah, that's not too difficult. Not too difficult. Let's go. W, yeah. Always use this Tuhi. Use this as a resource, dude. If you have stuff in math that's like confusing and doesn't make sense, like, let me explain it to you. Let me help you, you know? Maybe you get everything in class. That's totally cool. But if anything's ever difficult, you know, I know this isn't difficult for you. I know this is easy. I know you know how to do this. But if you get the stuff where you don't know how to do, or maybe you have like a little bit of a question, let me go over it with you. And also, I can show you shortcuts. Like, I know all the math secrets. All the secret shortcuts for math. Or I don't know all of them, but I know a lot of them. So if you want to like be able to do things quickly in math, I can show you those too. But I have to know like what you're working on. Cool. When exponents and Pythagorean theorem things come up, I definitely need to come here. Yeah. Let me help you with exponents and the Pythagorean theorem. I teach the Pythagorean theorem, I swear, like at least once a week. But it's totally cool. Like, please come by and I'll explain it to you. I've gotten really good at explaining it at this point. Okay. Yep. Okay, Jamarcus, this is Jamarcus's question. If 120 to the k is a factor of 200 factorial, find the greatest possible value of k? Jesus, what? Excuse me, Jamarcus? Jamarcus, what the hell is this? Is this one of these tough questions you have, Jamarcus? It's actually quite simple. Okay, well, let's see. Okay, so I know 200 factorial. Let me think about this. You know, I just see this and I'm just like, what's going on? But let's try it out. 200 factorial. For those that wonder like what this exclamation point is, it's not saying like 200. No, it's 200 factorial. And how factorial works. So say, for instance, we have 5 exclamation point. It's 5 factorial. This is 5 times 4 times 3 times 2 times 1. ... Well, it stops there. So basically, you take whatever the number is, you multiply it by the next number below it, and then you keep going down until you get to 1, and then you stop. Another cool thing about this is that 0 factorial is technically 1. I don't know why that is again, but it is. So just remember that. And so we can write out factorial in kind of like a generalized form. So I could say that n factorial is equal to n times, and then it's n minus 1 times n minus 2, right? Times n minus 3, and so forth and so forth. 0 factorial is 1. Otherwise, every n factorial equals 0. because it goes all the way down to 0. You're right. Yeah, sorry. This eventually goes down to, right, to 0 factorial. And this one is 1. Okay, that makes sense, Kiss Killer. I appreciate that. Yeah, okay. All right. 200 factorial is like 200 times 199 times 198, blah, 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 blah. Okay. So 120 to the K. Uh-huh. Okay, is this like just how many ways can I put 120 into this, right? Because if it's a factor, right, that means that I can pull a 120 out of something up here, right? And this eventually goes all the way down to 0, right? And I want to know how many 120s I can pull out. I know I can pull one of the 120s out at least, right? Because in this sequence, I will eventually have, for instance, 121 times 120 times 119. Okay, cool. There's a simpler way. Well, let me see if my way's correct. If my way's correct, then we'll see. Okay, so I know I can pull a 120 out. Okay, and now I need something else with a 120, right? There's no 240 in here, right? So I can't pull. For instance, I can't pull 2 times 120 out. Okay, what else is in this? Okay, so let's write out the factors of 120. Maybe that'll help. So 120, I could have, for instance, 2 and 60, and what else is that going to be? Sorry, 2 and 60, and then what? 2 and 30, 2 and 15, and then 3 and 5. Okay. So I want like another way. I know how this works. Oh, this is very cool, Jamarcus, actually. I like this. Sorry. 2 and 160, 3 and 40, 4 and 30, 5 and 24, 6 and 20. There's no 7. 8 and 15. There's no 9. 10 and 12. That's it, right? Okay, these are all like all the possible factors. So here's the cool thing, right? Okay, so in my whole thing here, right, I'm eventually also going to have, right, times 60. Well, here, it's going to be ... and it's going to be like times 60 times 59 times ... And then we're going to have times 40 ... And it's just going to keep going down. Anytime I see one of these pairs, that's another 120 I can pull out. Oh, very cool. I like this, Jamarcus. Okay, cool. So I know I can pull out the 120, right? That's 1 and 120. And then I can pull out a 120 from here, a 120 and as long as there's no overlap, right? So 1, 2, 3, 4, 5, 6, 7, 8. I think the answer is 8. Is the answer 8, Jamarcus? This is actually a very cool question. I like this one. It's 197? Wait, what? Wait, how's it 197? Sorry, what? Yeah, show me how you did it. I think there's 8. Okay, well, it depends. Is K an integer? If K has to be an integer, then I think it's 8.
And 197's an integer as well.
It is, but I'm curious how 197 works.
I hate questions like these. They're so pointless. No one's bothered.
Yeah, no one is bothered, but like they're fun. They're math puzzles. I do like these.
No, they're not.
Yes, they're puzzles. Dude, this is how you flex your math e-peen at people or something. You're just like, look, I can do these things. 120 to the K is 2 to the third, 2 to the 3K. Okay, wait, excuse me, what? Let's read this, dude. What's going on?
Blood needs to learn latex.
Yeah, we do need... Yeah, Jamarcus, we gotta teach you latex next. I mean, okay. I agree with the prime factors of... What was it, 120? 2 to the third times 3 times 5, right? Okay. This is equal to 120. So 120 to the k, I agree, is 2 to the 3k times 3 to the k times 5 to the k. Yeah, okay. Where's the 197 come from? Digital reproductive organ, yeah. We used to say this all the time in, like, back in the 4chan days. Oh, yes, thank you, Noise. Thank you, Noise, for the for the latex. Beautiful. Oh, wait, I have it wrong. The answer's 65. You use Legendre's formula? Dude, what? What the fuck is Legendre's formula? For the exponent of the largest power of a prime p that divides the factorial n. Okay. Man, dude, why they gotta put things in such fancy math language that's so... Oh, man, it's p-adic, dude? Stop. Stop. I do appreciate your questions for being difficult, Jamarcus. I'll give you that. I like my explanation better. I really do. Is this it? Is this Legendre's formula we're going to use? Okay, let me read this. For any prime number p and any positive integer n. Okay, well, first of all, like, 120 is not prime, and neither is 200. Okay. Yeah, okay. 120 is certainly not prime, though. Like, I just use 2. Okay, sure. I'll use 2. Yeah, 2, 3, and 5 are prime. Okay. Because the exponents of 3 and 5 will always be smaller. Sure, I can find out all the factors of 2 then, but I also need it to be the same value of k for 3 and 5, right? I feel like I need Hypatia on this one. Where are you, Hypatia? The answer is cheeseburger. No, the answer is potato. I realize actually there is something slightly wrong with my methodology for doing this, is that I don't include the triples. So I only included pairs of numbers that work. So
I've got k equals 25.
You got k equals 25? Do you want to show us how? You want to show me why it's 25?
I can write it out, yeah.
Yeah, can you write it? Do you know how to log into this board? Did I give you the directions before?
I mean, I was just going to latex it, but...
Okay, you're just going to latex it. Yeah, show me. Show me, please.
I mean, I think it's a very, very, very botched solution. I don't know if it's true.
I'm realizing that... So my intuitive way of doing this is cool and, like, kind of correct. But the issue is that I don't have the doubles. I don't have the triples. But... Yeah, wait one second. It's like 120 is 2 times 2 times 2 times 3 times 5. Okay, but then what are the combinations of this?
Oh yeah, no, it's not 25. I got 66 actually.
You got 66? I still think the answer is 8. I like my method better. Is your solution Noise? Is it using this? Are you using this Legendre formula thing?
Yeah,
Okay.
I just did. What's that? 200 over 8. Well,
Well,
2
200
cubed is a prime factor, isn't it?
2 primed is
So
a is a prime factor, sure.
Yeah, so I just did 200 over 2 cubed. That's 25. I did 3 is another prime factor, so I did 200 over 3. That's roughly 66.
No, it's
and then
67. Oh, it's the floor function. Oh, okay.
And then I did. Yeah, I did the same thing for 5, so
Hello.
200
What's up,
over
Teacup?
5, that's 40. Biggest one of them, 66. So I'll just put K equals 66. Biggest
Yeah, no,
value of K.
it's a little confusing. So they say 200 if 120 to the K, what's the big... Okay, so for instance, you know that 200 factorial for sure at least contains, right, 120 in it as something in the top number. So you know that 120 to the first is most definitely a factor of 200 factorial because those will cancel out. My other explanation for this is also that, for instance, as you go down the line, you're going to have a 60 and then you're going to have a 2. And 60 times 2 is also 120. So you could also have another 120 that could cancel it out. So in this case, that would be 120 squared. 120 squared is also a factor of this because it'll cancel out 2 of them. I don't understand this. This to me is just like a bunch of fancy math words and stuff that I don't know. I don't get it yet. Y'all are smarter than me in some of this higher level math stuff. But eventually 120 to the K will be greater than 200 factorial, so it won't be a factor. I agree with that. Yeah. Like, for instance, if K was 200, right? 120 to the 200, that would be 120 times itself 200 times. And that's much bigger than 200 times itself, a lot of times going down. Every second number will be divisible by 2. Every fourth number will be divisible by 2 squared. Every eighth number by 2 cubed. Yeah, that's a lot. Okay, but then what about the 3s and the 5s? Oh, okay. I think I'm starting to see it. Yeah, okay, so 200 divided by 5 gets you 40, right? 200 divided by 3 gets you... So isn't it the lowest number then? Right, so, 200 divided by 3 gets you 66. 200 divided by 2, right, gets you 100. 200 divided by 5 gets you 40. Doesn't it have to be the lowest one? Because at the end of the day, you have to have... you have to have a 5 in there somewhere, right? Because it has to become 120. In order to become 120, I need at least 3 2s, 1 3, and 1 5. And then I can have multiples of that. Yeah.
I don't know why you'd want to do this question.
Yeah, it's kind of a mindfuck.
Not fun.
All right, Jamarcus, I'll give you a point for it at least. It was cool. Yeah, but I have to wrap my brain around it more. Greatest value k, which will be less than the factors of 200 factorial. Yeah, okay. I guess we think
I'll even know that in an exam though, because you can't just do 200 factorial in your head.
No, you can't. I mean, this is again.
Or 100.
They do questions like this.
25 in your head.
Right, dude. Even if I like tried to pull up the calculator, you want to see if the calculator will do it? Let's see if the calculator will do. It won't. It won't, dude. Oh wait, I need to put my calculator above the chat. Sorry. Yeah, if I try to do like 200 factorial, I don't even think it'll do it. Oh, it's in like. Sorry, I gotta go to the catalog and find it. It's down here.
Don't use ChatGPT.
Check what ChatGPT can't do math. We've already said that. Okay, let's see.
Actually,
Does this even come? You see, overflow. Yeah, you can't even do this. You think Wolfram can do it?
Well, no, ChatGPT said k equals 25, like I initially said. And then
Okay.
I changed my answer.
Well, here, let's do this. Let's do 200 factorial, right? Divided by, what was it? It was 2 to the third times 3 times 5. And then we said this was to the 25, right? Let's just see if we'll do it. I think this is like trying to approximate it. Skews number, dude. Gamma functions, dude. What's going on, dude? Stop. Yeah, I don't even think this. Wolfram doesn't understand your 200 factorial.
Why 65? Why not 66?
I mean, yeah, this has 375 decimal digits. I don't know. It's just too big. Yeah. Again, this is math. I don't know what gamma functions are. I don't know what the Pachymer symbol is like. We just start getting to like weirdo math language place. Yeah. No, I don't know these ones.
Weirdo.
Weirdos. Okay.
A gamma function's just the analytic continuation of the factorial function extended to complex numbers.
I understood maybe 25% of that.
There's factorials for complex numbers.
Okay. I like factorials. I just don't like 200 factorial. That's a big number, dude. 375 digits. It's just like, no. Here, let me help Echo with some history. Let's see what the history is. I like this. Oh, it's multiple choice questions. We got some multiple choice history questions.
Oh, I've got a physics test tomorrow.
Oh, do you? Oh, did you send your stuff for us to go through? Do you have some physics stuff we can go through?
Oh, no.
Do you need help with your physics stuff? Do you have like a practice test?
Fuck it, I'll find one.
Yeah, go find one. Yeah, let me help you with a practice test. I think you're doing like E&M and stuff, right? Because you were asking about electric fields and things, right?
Yeah, I don't like it very much.
Yeah, let me help you out, dude. I got you, bro.
And again, I don't like physics.
I got you, dude. I got you. Dude, physics is the best.
No, it's not.
Yeah, it is. It's okay. No, so we're going to convert you, dude. We're going to convert you to statistics, probability, all that fun stuff. We're going to do it.
What the fuck?
What the fuck?
Look at this. I've just tried to look up electric fields question paper, and the first question is about fucking gravitational fields.
No, you don't need to do gravitational fields. Yeah, Jamarcus, Jamarcus, yeah, send me some work. Let's check it out. Wee. What's up, Dark? Okay. Let's see. Echo Chaos. What's up? What's up, dude? You have a question about history, I guess is what it is. Here, pull it back up. Okay. Select all that okay, so this is where like tutoring for history or even like biology and whatnot is really just about reading the passages and knowing where to get the information from. Again, do I actually know this question? Who knows, man? Like I don't even know what the Enlightenment period is. Like what? Where did Enlightenment thinkers get their inspiration? From authoritarian government systems, from the nobles and clergy of the time period, from the ancient Greeks, from Judeo-Christian culture. Okay. I don't know this because again, I'm not in your history class. So this probably came from some text that your teacher told you to read, and the question is, where do you go find it? Right. I'll show you how I would do it if I was just given this question, I had no clue and I didn't do the reading or whatnot. And that's the internet, right? You can probably just literally Google this question, right? Like, where did Enlightenment thinkers get their ideas from? Humanism of the Renaissance, classical literature, antipathy towards perceived religions. Okay, so antipathy means they didn't like religious dogma, right? They didn't like religious stuff and whatnot. Oh, I like this. Cool. They questioned ideas. The Age of Reason. Okay, it's a cool period of time, I guess. Question traditional authority and embrace the notion that humanity can be improved through rational change. That's cool.
So you have diabetes. And
I don't have diabetes. Excuse me? Jesus. All right. Isaac Newton. That's cool. John Locke. These are all cool things. I mean, these are all very, very science-related things. But based on this, right? Based on this information.
Thomas Jefferson was born in
Jesus.
1743.
History Channel, your commercials, dude, need to chill. Okay. So it seems that they rejected a lot of classical things, is what the Age of Enlightenment is. And so based on that, right? And they said they rejected a lot of religious stuff. So I don't think they got I don't think they got it from this. I don't think it's from religious culture. They said they reject, and it seems like they were also against authoritarian governments, right? It says here that, you know, that they question traditional authority. So I would think they got I think they got rid of this too. But then it also says,
Is that not that thing where, you know, when the... Oh, what is it? They nailed all them, like...
yeah. John Locke. Or the Protestant guy, right? Was it John?
Yeah, that's it.
John Locke nailed papers to door. What was this? Oh, no, it was Martin Luther. Martin Luther. That was his name.
Ah, yeah.
Yeah. He nailed a piece of paper to the door of the church in Wittenberg, Germany, and gave 95 opinions that started the Protestant church, basically. That's cool. Yeah, he's basically like, right? Yeah. Okay, history is important, not to just memorize like random dumb facts and shit, but in order to understand the trends that humanity goes through, I think, in order to try to predict what we're going to do next. Because we are creatures of habit, and, you know, history does tend to, quote-unquote, repeat itself. So that's why history can be interesting, is to see how did we behave in the past and try to predict how we're going to behave in the future. I agree with that. That's a cool part of history. But just like memorizing like dumb facts, like how many teeth did George Washington have? Like, who gives a fuck? Like, what? It doesn't do anything. Also the question of, it's saying inspiration. So, I mean, I feel like they were definitely inspired by, again, the church. They were inspired to, like, hate it. They were like, this stuff sucks. So, I don't know. I think this is kind of also... Yeah, this is kind of a shitty question. Like, where did they get their inspiration? Inspiration can mean a lot of things. Like, what supported their beliefs, or what caused them to think that they didn't want to do this shit anymore. That's also inspiration, right? I get inspiration on how to change my diet after I eat a bunch of ice cream, and I feel like garbage. But it's I don't know if it like inspired me in a good way, but it definitely inspired me. Yeah, inspiration in a rote memorization way. I agree. Yeah, this is kind of weird. Also, I hate when they say select all that apply. This is like the motherfucker of all questions. When they say like, some could be true, some could not be true. What was the answer, Echo, for this one? What was it?
Has to be both of them, right?
I think it's probably these two.
Yeah.
I don't think it's this. I don't think they like the
It's
Christians.
definitely
And I don't think the authoritarian governments.
Authoritarian.
Yeah, right?
Eat the rich.
Eat the rich, dude. Eat the rich. I think it's probably this. The two that aren't scribbles. Oh, yay! Look at that! Alright, we're doing alright. Okay. Here, let's try. I want to try and get this one. Ooh, yeah, see? Okay, we were kind of correct. That's dope. You can be critical and not select any, and then you can be liberal and select everything? Yeah, I agree. Okay. What was an effect of Enlightenment ideas on the political world at the time? Let's see. I bet there was a bunch of repression. Some government leaders attempted to govern as enlightened monarchs. Women achieved more momentum in gaining the right to vote. Women couldn't vote till like 1900s. It's definitely not this one. Yeah, what? I don't think so. Like, women couldn't vote till the 1900s.
Most monarchs changed the approach to governing bollocks. Definitely.
Well, they probably changed their approach to like just oppressing the shit out of people. That's probably what they did. I don't know.
It's C.
I'd say it's C. I'd say C. C sounds like the happy answer, like the answer that we would like for this to be. And sometimes this does happen with history. This is another problem with history. History is subjective, right? Math is not. Math is either right or wrong. Well, at the lower levels of stuff, like it's 2 + 2 is 4. That's it. Like it's right or wrong. History is they say written by the victors or written by the winners, right? So you can put any sort of lens onto like what happened in history based on who you are. I'm sure, if the Nazis wrote history, they'd probably write themselves a really nice thing about World War II, Even in U.S. history, I know early textbooks probably kind of swept under the rug what we did to the Indians. They were probably like, yeah, no, it's okay. We just, we gave them nice land in middle of fucking nowhere, New Mexico. And, we took their land. But in reality, like, we were absolutely brutal. But they're not going to put that in the history books because we look bad. Oh, this one was that. Oh, okay. Noise. He says this one was this one. Some government leaders attempted to govern as enlightened monarchs. That's cool.
No.
Were they like faking it till they make it type stuff? Is that what they did? I feel like that's what they did. I'd go eat dinner. Oh, all good. I like this. This was fun.
He's going to do my question.
Yeah, let's do your question. Where's yours?
This.
And then I'll do teacups. Ooh, I like this. Yes, hola. Yeah, let's do this, dude.
Fucking equipotential.
We love equipotentials, dude.
Alright.
In steps of oh, okay. So this is like a contour graph, is what this is. This is kind of cool.
Yeah, sort of. That's how I understand them.
Yes, yeah, exactly. And then also, the way to understand this, right, is that in equipotential, the strength of the electric field, right, is how close the lines are to each other, right? And you can know this, right, because isn't it E is equal to negative grad V? Is this what it is? I think this is what it is, right?
E equals delta V over delta R.
Right.
The negative one.
But do you know this? Do you know this symbol? Do you know what this is? Gradient?
Yeah.
Yeah? This this points in the direction of where something's going, is what it is.
Yeah.
You'll learn these, right? So there's this is called divergence. This is called curl. And then this is called grad. Okay. Yeah, these are important things that you end up doing in a lot of E&M. A lot of E&M ends up doing div grad curl. And then there's some cool math sorry. It's div grad curl. Okay. And there's kind of like a ring around the rosy thing here, where the divergence of gradient is equal to curl. So for instance, the divergence of gradient is equal to the curl of something. And then the curl of the gradient is equal to the divergence. Or sorry, let me do this like this. These are called vector identities, is what these are. This is very cool for vector calculus. You'll end up doing this a lot. You haven't seen this yet, Noise? You haven't seen this stuff in your math travels?
I haven't done vector. I haven't really touched vector calculus.
Oh, vector calculus is you would love it, dude. It's like linear algebra, but like with calculus. Anyways, okay. Right. Okay. So a point charge. Do we know what the electric field of a point charge is? What's the electric field of a point charge?
What is it? Q over 4 pi epsilon naught.
Yes. Good. It's Q over 4 pi epsilon naught over r squared is what it is. It's r squared.
Oh, shit, is it squared?
Yeah, it's squared. And then the important thing here is, okay, so 1 over 4 pi epsilon naught, that's also the same thing as k. So we write this as like kq over r squared, right? And then you can actually get the expression for potential, okay? Because the change in potential is equal to the integral of E dot dr is what we say. And it has to be from some, like, we say like r is equal to infinity to r is equal to r, basically.
Yeah.
Right? And this is how, when you integrate this, right? Oh, and it's the negative here. This is why you get kq over r. Because then it's negative, but then it's like, it's 1 over r minus 1 over infinity, right? And this one goes away.
Yep.
Cool. All right. So, okay. Equipotential lines from a point charge. If you have a point charge like this, right? It radiates electric field like this, right? Well, really, sorry. Radiates electric field like this is what it does, right? And what a potential measures is how much electric field do I have to go through in order to get to a certain point. And because of the spherical symmetry of a single point charge, the electric field propagates out as a sphere. That means that there's going to be a spherical shell around it where getting to that point is always going to have the same amount of potential. I always like to describe electric potential similar to gravitational potential, in which it's where energy gets stored that could get released into kinetic. For instance, right, if you hold a box up in the air, right, this has what we call gravitational potential, MGH, right?
Yeah.
And then what happens if I let go of the box?
It gets converted to kinetic energy.
Good. Yeah, it falls down to the ground, and all this potential energy gets converted into kinetic. It's the same thing for electric potential. If you have a charge, right, and then I place another charge over here, these two things want to fight each other, right? You know that from Coulomb's law, right? So this has a potential because if I release this thing will run away and convert that energy into kinetic. So that's kind of where the concept of electric potential comes from. And then there's also electric potential energy, which is technically different. So UE is technically equal to Q times V. And it's kind of in the same way that UG is equal to like MGH. You're just adding basically how much of mass there is. In this case, the equivalence of mass in electrical forces is how much charge you have. So that's where these things come from. This is why physics is cool, Noise, is because everything seems to follow the same pattern. Like, there are analogies everywhere. There seems to be something that unifies all the forces, whether it's, gravitational forces, electrostatic forces, magnetic forces. There are these weird similarities in all the formulas that you start to think there's got to be something that connects it all together, right? I don't know. I'm trying to inspire you to be. This is why physics is cool. He's not convinced yet.
A-level physics almost made me a Christian.
Almost made you a Christian.
When I was teaching you about that particle physics stuff.
Yeah.
This is a load of bollock.
Yeah. They kind of jumped in like too fast at that point. That to me is like, you can dip your feet in the water and slowly like warm up, or you can just do a cannonball on the deep end. And like going straight into particle physics with gluons and mesons and stuff, that's just diving right in, and you don't get any appreciation for it because you haven't seen how all the simpler stuff works. Yeah. I don't know. Anyways,
I like that topic.
It was cool. No, I
I
appreciated you teaching it to me. It was very cool. But Okay, so which one do you think this is? Which one of these do you think is the potential difference next to a point charge?
Well, it's either C or D.
Good, it's either C or D. Yeah, good. I agree with that. Right, yeah, cool. Yes. Okay. So yeah, it can't be this, right?
Isolated means.
They just mean like a point charge just by itself, just a point charge like this, right?
Okay.
What we know about the potential, though, is the potential goes as 1 over r, right? So the potential should be decreasing as we get further away, right?
Oh yeah. Okay, so it's D.
I think it should be D, because, right, and the way this also comes from, right, is that again, electric field is equal to the gradient of the potential. Okay, gradient just measures basically the slope, right? If the slope, in this case, since the spacing between these all are constant, you would imagine that the slope of that would be constant as well, which would basically mean the electric field is constant. But the electric field is not constant for a point charge. It drops off right here as 1 over r squared, right? So I need something where the gradient is changing as I get further and further away, and that's correct here, right here, because like the distance between things are changing. Yeah, is that right? Is the answer D? I'm pretty sure the answer is D.
Yeah. I haven't checked. It looks right.
Yeah, it looks right. It looks right. Okay, we'll take it. We'll take it. We'll take it. Yeah, dude, I love physics questions, dude. Yeah, lay me up more of those. Give me more physics questions. I think we have time. I'm going to do Teacup's question, but then, yeah, give me some more physics questions for your test. Kisskiller says, 1K pay... It's bedtime for you? What time is it, dude? Oh, it is bedtime for you. What? No, it's like midnight. Midnight,
Oh, yeah.
1 a.m., 2 a.m., 3 a.m. It's one of my favorite Boys Noise songs.
I'm actually speaking this time, so.
No, I appreciate you speaking. Oh, when do you find out about your new job?
Not a clue.
Okay. Well, let us know.
They email us back.
Yeah, let us know. What did you apply for again?
Yeah, so working in a tech shop, so I might end up like selling TVs to folk who
Yeah, that
don't
sounds
have a
better.
clue about TVs and
That sounds like a much
washing
better
machines and
yeah, there we go. Electronics. That sounds like a much better trajectory for you than working in a warehouse, like shoveling dog shit and stuff. Yeah.
I like the warehouse.
I know you like the warehouse, but like, let's get you out of the warehouse. Like, otherwise you're not gonna know what the square root of fuck anything is.
Oh, yeah, true.
Let's not do that, Noise. You're too smart. You're too smart, Noise, to be working there.
I don't like it. I don't like saying that.
I know. You don't have to say it because you don't want to be pretentious, but let me say it. I can say it.
Well, it's not pretentious though. It's like they're just as smart as in like street smart. Like I mean, I can read a maths book. Fair play.
You're too math smart to not be doing something in a math smart place, or at least some sort of tech or science or something. You know, TV shop is we're getting in the right direction at least. You know, if you told me that you applied for a flower shop or something, I'd be like, no, wrong direction, Noise. Head towards the electronics. He's like, I like a flower shop. I know.
I water the plants at work. It's good.
I know. There's nothing wrong with watering plants and having hobbies and flowers, but yeah, let's get you into something that uses your unique advantages. Noise is what I would say. That's actually okay. That's a big thing. That's a big thing I'll talk about just real quick. You got me on a fucking lecture stand here now, but yeah, you talk about how like everyone's smart in their own way. I totally agree. But I also believe that people have unique skills that they need to realize and then use those in the best way possible to help, I guess, society and whatnot. It's why we have, for instance, division of labor. We've had this since, thousands and thousands of years ago, right? This is just how biology works, is that you need certain parts of the species to do something and certain parts of the species to do the other things, because if one part of the species tries to do everything, like everything screws up. You need to divide the labor in order for the greater whole good to do well. And in the case of, some people are book smart, some people are math smart, some people are very just people smart, and those people end up becoming probably therapists or I don't know, politicians or something, people that can like deal with people. I'm sure you've seen that a lot of people that are really good at math absolutely suck at dealing with people, right? They don't have the best social skills. It's okay.
Lots of dealing with people.
No, you're good. You're good. But some math people I know that are incredibly brilliant at math and whatnot, they have no people skills, and that's okay, because their purpose here, I think, on Earth is to do the math. Let them do the math. Don't try to make them like a basketball coach. They're not going to do very well at that. But give them a pen and paper and tell them to go like solve the mystery of the universe with math. Like, yeah, that'd be cool. I had the same realization when I was in grad school. I was like, I'm not the best physicist. I'm not the smartest physicist, but I'm very good at communicating what I do in physics and being able to explain it. And I was very resourceful, I guess, also. I was able to like do a lot of, and that's why like I went into experimental physics instead of theoretical physics, because I knew I was pretty shit at doing the pen and paper equations and theory work, but I was a lot better at being able to build circuits and probes and analyze data. And so that's where I'm like, okay, I'm going to go do this. It's not to say that my theory friends are smarter or dumber. They're just better at a certain type of physics, and that's why they do that type. So, yeah. Rant over. Mm-hmm. He's like, uh-huh. You probably feel the same way I used to feel when my dad used to always just rant at me about like stuff. But it'll get to you eventually. I know. You'll get there. Kisskiller says 1K pages books are a lot for me, especially in PDF form, and they feel slow. What is your advice for me? Oh, okay, because Kisskiller's teaching himself math. Well, maybe Noise can help with that. Noise, how did you like teach yourself math in a way that wasn't like blowing your brains out?
Read the Wikipedia article and made some sort of sense of it.
Okay, so Kisskiller, he says reading the Wikipedia article.
Rampton.
Rampton what?
He doesn't really approve of my methods.
Yeah, I agree that like a big 1,000-page book can be daunting. Is there a specific article or what?
Depends what you want to learn.
Yeah, it depends what you want to learn, I guess. Books in general are good because they structure their learning in hopefully a way that makes sense. So, for instance, that calculus textbook I hope I gave you, it structures learning calculus, like learning the different parts of calculus in an order that makes sense, because a lot of times to learn more advanced math topics, you have to have a solid understanding of simpler math topics, and knowing which ones you need to know, that's what a textbook does. A textbook says you need to know this and this and this and then know this. Yeah, what's up, Hypatia? Hypatia is probably a great example of self-discovery in math as well,
I don't have a choice.
Don't have a choice, right? Well, okay.
By the way, I just like I just wrote an email to my like our math department education program person saying I'm willing to like curricular reform, textbook writing.
Oh wow!
Interactive animations from Lua Tech to JavaScript to GLSL or anywhere in between. I think. That's dope.
If
we are up for it, so I definitely want to push for these changes.
I think that's great, Hypatia, and I've always appreciated your desire to reform, again, the kind of monotonous and mechanical way that we teach math.
I mean, this is something. It's this reform can be done. It's not something very idealistic, very unrealistic.
Yeah. So Kisskiller is asking Hypatia, you do graphic stuff, and like I'm pretty sure you do, right? You do graphics.
Computer graphics, also computer vision too. I mean, it's fun. I do all sorts of stuff, and then I do it really well. I see different connections about different kinds of things.
Kisskiller says he wants to learn calculus. Hypatia, if you were in Kisskiller's shoes and wanted to learn calculus, what would be the best way for you to learn calculus?
That depends. Like, what do you want to get out of it? Like, if, for example, if you really want to become a mathematician some days, just read some analysis textbook. It will serve the best. I can recommend some. If you want to do computer science, there are more engaging materials. For example, how physics engine work, how rasterization work, how ray tracing work, how like those kind of things. Like if you want to write games, for example, if you want to do CV, what's gradient descent, what's symbolic differentiation, what's like back propagation, neural models, genetic models, blah blah blah.
All sorts of stuff. Yeah, I think so. Kiss Killer. Correct me if I'm wrong, Kiss Killer, but I think Kiss Killer went to university, got kind of discouraged by the whole math learning process there, so decided to take a break, and is now working on self-teaching himself math, I guess. And so that's a good question, Kiss Killer. What is your eventual goal? Are you trying to be a mathematician? Are you trying to be a computer science person? Hypatia's touching on exactly what I want to do. Yeah, that's great. Yeah, please, Hypatia's here. Hypatia's a great member of our server. Like, if you ever want to ask Hypatia questions, send them a DM, please, and Hypatia will definitely point you in the right direction for that stuff.
I don't really check my DM that often, so just at me on this server.
Oh yeah, or just at. Yeah. That's another thing. Yeah, you can always just at people and then in public channels and stuff, and we can figure it out for you, Kiss Killer. Because I'm sure there are other people. There are other people that find this Discord that self-teach themselves math and whatnot.
What kind of thing you want to do though? Like, I don't know. Like,
yeah, it all depends.
Describe it a little bit further. I offer great general mathematical advices too. Like today, it's horrible. Like there's another person who, like the student they are tutoring, they are already asking very insightful questions about, say, differential forms,
Nice.
or things like that. What exactness actually means. And the person is very discouraging. And also there's another student who is like working on their own proof of a formula. I think I should help them. I took a picture of that, and that tutor just said, "No, it's not required by the course. It's
extra work."
Like the person is already eager to learn mathematics, and you started to discourage them. That's horrible.
Yeah, that just like beats it out of them. Yeah. So Cusco says, I know the basics, functions, algebra. Yeah, Kiss Killer. What do you want to do though? That's the question. It's okay if you don't know what you want to do. If you just have a general interest in math, that's still cool. You'll figure out what you want to do in math as you go down that road.
Algebra, as in the algebra of regular functions.
Yeah, I think just basic stuff. I don't think Kiss Killer has even done calculus yet.
No, okay.
Yeah, all good. There actually was a good question. Hypatia,
what?
We had a question that came up that Jamarcus asked.
Which one?
It was here. I'll put it on the stream. It was this one. So it was something with like Legendre's formula and like p-adic stuff, and like I was like, I don't know what's going on. One second, let me put it on the clear screen.
That's my I study that.
Well, that's perfect. Then maybe you can help explain this, because like I can't get this. So
I was thinking, I really like when students ask me unexpected questions, because the lecturer will just tell them to go away, don't think about it.
Yeah.
And like today, somebody asked me what's the antiderivative of x times tangent of x. It's a non-elementary antiderivative. It can be expressed as a Eulerian first like special function,
Sure.
and then you can prove the non-elementariness by Trick's theorem, differential Galois theory. Yeah, but I definitely want to give my students all
that's
the
good.
answer.
You're an inspiration to that. That's great. That's really great, Hypatia.
Any prime number p and any possible and the exponent of largest power. Yeah, that's the periodic evaluation.
Okay.
Yes.
How does this work?
I just predicted what they are going to say.
Okay, that's dope. All right, how do we do this one?
VP n factorial, or does that mean something different? I think that's the factorial. Yeah,
This is factorial. I think it's factorial. Yeah.
And the floor or the sum on the right side is an infinite sum. Yeah, for any particular value, it has only finite many non-zero terms for every I large enough.
I think we.
So you want to prove that?
No, we want this answer. This is I think a supporting theorem that helps figure this out. We want to know what's the greatest possible value of k, such that 120 to the k is a factor of 200 factorial.
Okay. Let me think of it. 120 to the k is a factor of 200.
This was the prime factorization we came up with.
I mean, you don't actually like. I don't think you need to really use the like you don't have to use the periodic analysis. You can just think about it and then figure it out. Because
Okay. I couldn't figure it out. I tried to write out the factors of 120, right? Which I knew were, right, 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, 10 and 12. That's what I came up with. And I thought of, oh, if something is 200 factorial, right, then that's the same thing as 200 times 199 times dot.
Yeah, look at the periodic valuation that it's telling you. It's basically saying that you want to put V of, let's say, V of the each
Each of the prime factors.
Yeah.
Okay.
And then you put n factorial after that, and then you do that computation. Like that still requires a lot of computation. Like, yeah, you just do that, and then so these are saying they are the greatest possible exponents for like greatest possible k for each of the primes.
Yes.
So now you just find the smallest one.
Oh, I see.
among
Yeah,
them.
the smallest. Okay, yeah, so it's the smallest one, right? So that would be 25 then, I think, right?
And then you also have to think about how you would do the 2 to the third.
Yes.
Let me think of it. So it's probably best just.
I don't know. This one was kind of a stumper. It kind of it stumped me. I was like, oh no.
In periodic, like number theory or things like that, but yeah, just try that. Like, try 2, 3, 5 first,
Mm-hmm.
and then like
And
if you
evaluate this?
have- Yeah, if you have say 122K, that is the largest power that divides.
Because if this is 120, right, Hypatia, then 120 to the k must be 2 to the 3k,
Wait,
3 to the k, 5 to the k.
The exponents of the largest power of p that divides n. Okay, so n is not 120, n is 200.
And it's 200. I agree with
Yeah.
that. This is 200. Yeah.
Yeah.
And then p is the
So
power.
here, yeah, p are the 2, 3, 5. So if you say this v2 200 factorial will be the exponent of the largest power of 2 that divides 200, then you can just divide that valuation by 3. Because, yeah.
So that becomes 100
Like-
divided by 3, so that becomes 33 then, right? If I do,
Let me think of it.
because p is a prime
so-
number, right? So p is 2. So it's
Yeah.
200 over 2, that gets me 100. But then because it's like to the third, right? I got to divide that by 3 again.
Try work on a smaller example, a tangible one, say.
Yeah, one that you could verify, right? By just doing it by hand.
Like, say, just. If you have, say, two, on the right hand side, you don't need to even do n factorial. Let's just say v28. So v28 will be 3.
Okay.
And then now if I want to do v88, that will be 1. So yes, this is correct. You just evaluated that series.
Oh,
and
I see.
then
I
you
see.
start-
Like 8 to the 1 will go into 8, and 2 to the 3 will go into 2. Will go into
Yeah,
8.
you just divide by 3. This is much more simple than
I like this.
originally expected. So yeah, just do that.
Okay, I got you. But this is,
So
and then we got a summit from I equals 1 to infinity. What is this
yeah,
going?
yeah, I think it's a approximation formula, or no, it's not approximation.
But then it's interesting. It's a floor function, right? Anytime I see something has a floor function, it's got to be an approximation.
Like, this might be the periodic analog of Newton's methods, which is called the Hensel's theorem.
Uh-huh.
But you don't have to worry about all of that. You just accept the bottom one, and then you start working on it. So n would be 200, and then p would be 2 to the I. Now you can see what the sum is will actually be, right?
Mm-hmm.
And then yeah, it has only finitely many non-zero terms. That's a result of also the periodic valuation. So it does it. Oh yeah, it actually is not a series. It's just a. Yeah. Do you know how what I'm talking about? Like, do you know how to do it now?
Yeah. I think I have a better idea about it. Here we see.
Yeah, try it. Let me go get my food. I will be away for 2
you're
minutes, and
you're
then
good. You're good.
I
You're
will-
good.
The computer did
If this thing for is 8, you were doing p equals 2, you wouldn't have to go to infinity just until 4. Oh, okay. Yeah, let's say it was 8. Okay, so let's say v2 of 8. I don't think the p-adic stuff matters. Okay. 8 divided by 2 to the I. I see, but then this only goes up to 3. Right? For any prime number p, any positive integer 8, let vp of n be the exponent of the largest power of p that divides n. Okay. So vp of n factorial. Okay. Just until 4. Yeah, I feel like the article does overcomplicate it. Yeah, this happens all the time with Wikipedia and math. They tend to like make things like way too complicated.
did you get it?
I'm slowly getting it. I'm slowly getting it.
Let me just do it for you.
Yes, please. Yeah, please show me. I'm expanding my brain today. Expanding my brain.
Mathematics is showing up. Okay, let's do. Can I erase the it's n? Okay, I got it. So
Oh, yeah, you want me here? I'll put this on a new page for you.
wait, don't go away. I'm inputting it.
Oh, there you go. Okay, there you go.
Sum 1 to infinity. Okay, sum I from 1 to infinity. Okay, let's do floor in over
I see.
p to the I, p to the I. Yeah.
Okay, I see it. Because if you don't have to go to infinity, because if I is big enough, then the floor function goes to 0.
Yes, this is actually a very important thing. It corresponds to every prime, like every number theoretical prime, when you pass it to a particular completion at a particular non-Archimedean place. It's a ideal. So it only ramifies at finitely many places.
Okay.
I think that's what how it goes. So let me finish writing this. Into 200, the p2 2. Yeah, that's it. Right. Oh, actually, no. Let's do another thing.
Mhm.
Let's try something else. So once you get 1 0, the next one will be 0. So
Yes, you can stop once you hit 0.
yeah. So let's do a. I don't know how to write it. Like Mathematica doesn't have that function that you can.
Say just stop at 0.
Yeah, let me switch. I will switch to Haskell. The, okay. This is stack, this is CI, and if you have another person's question, you can go on and answer them. I will
Yeah, let me
finish this call now.
Awesome. Yeah, let me do Teacup's question real fast, and then I'll come back to this. What's up, Teacup? Teacup, Teacup. Teacup. What do I gotta at you again? Pascal, I think, is what he's writing in. Teacup.
Pascal, not Pascal.
P-A-C-A-L, right? Pascal?
No, H-A-S-K-E.
Oh, Haskell. Oh, Haskell. No, you're right. You're right. You're right, Kiss Killer. There he is. Okay, Teacup. Let's do it. Let's see. What did you bring this? Haskell functions. Love it. Yeah, dude. Yeah. Page 108.
Hello.
What's up?
I have a test tomorrow
You're gonna be fine. You always do fine.
in AP Human Geography.
Oh, that's gonna be easy, dude. That's gonna be super easy for you, dude. What? You're so what? You got this, dude.
Well, the current highest score is an 8.
How hard can human geography really be, dude?
I got an 80 on the vocabulary.
Oh, well, vocabulary's whatever. Let's see. We're doing derivatives and stuff. Let's see. Let's do limit. Did we do the limit definition with you last time? I think we did, right? Teacup?
I'm gonna be completely honest. I got sick over the weekend.
Oh, no. Yeah, everyone's getting sick these days, dude. Okay, that's all right. Let me think. Okay. Let's try to remember. What do I want to do with you? I feel like I want to do the equation of the tangent line. Well, yeah, let's do this. I don't think you need to do the limit definition anymore. That thing sucks, honestly. Yeah, power rule's great. Okay, cool. And then let's do. Yes, I like this. Let's do this. I like this. We'll do one of these. Copy. Okay. We'll eventually get to that stuff. Okay, let's try this one, Teacup. It says compute f prime and then find an equation of a line tangent to the graph at x equals a. Okay? Do you know how to do this one? Teacup. Teacup.
Okay.
Yeah. Do you know how to do this one?
Hello.
Yeah. Do you know how to do this one?
Okay. Let's see. FX. I don't know what tangents are. I haven't done them.
We'll get that. Let's calculate the derivative first. Okay, and then I'll teach you about tangents. Okay? I'm gonna just paste that later for noise. If he's still here. This is a function, right? F of x is equal to x to the fourth. And I want to find f prime of x. What is f prime of x?
Yes.
What is
F
that?
prime of x is after after we graph it.
No, it's the derivative. F prime of x is the derivative of this.
Okay, so it would be 3x. No, it would be 4x to the third.
Good. 4x to the third. Okay, awesome. That's the derivative, okay? Let's remember what the derivative is. What is the derivative like intuitively? What does it tell me about a function?
I don't know.
Okay. It tells me about the slope of a function is what it does. Teacup. Remember this.
So I thought, oh yeah.
Derivative is the slope, okay? This is why calculus is so cool. So derivatives teach us all about rates of change, like where things are going, whereas integrals teach us how to like get the area of things. Right, exactly, yeah. So if I have a function x to the fourth, which you can graph, right? If I wanted to graph this, here, I can just put it on my calculator, right? Let's just graph x to the fourth real quick. X to the fourth, right? This is what the function ends up looking like, right? It's basically like it's a super hyperbola. Okay.
Yes.
Okay. This function 4x cubed tells me what the slope of this function is at different points. So for instance, at
So,
0,
slope.
at 0, right? What's the slope of this function at x equals 0?
4x to the third.
No, it's 4 times 0 to the third, right?
Oh.
F prime
Oh,
of
yeah,
0.
the x is the coordinate of which was.
Yes, exactly. That's where I'm finding the derivative, right? And you can see that. So here's the cool thing. The derivative of a function is also what we call the slope of the tangent line. Okay? Equals slope of tangent line. All right? And what I mean by the tangent line is a line that basically touches this here at one point. So it does something like this. This is like a tangent line. Whereas this would also be a tangent line. It kind of points at like where the function is going next, is what we say. Okay? Now, that's why, for instance, here, the slope of the tangent line is 0, because the derivative is 0 at x equals 0. And you know, it's flat. The function isn't really going up or down. It's just staying flat here. Okay. So, they want the equation of a tangent line at x equals a. And in this case, they want it at x equals 2. Right? So that's going to be like somewhere over here, right? 2. They want to know what is the equation, or let's make this 2. Let's say this thing right here is 2. Okay? Let's say this is 2. They want to know what's the equation of this line. All right? So, do you remember what the equation of a line is? What's the formula for it?
Y equals, not my slope.
No, it's okay. Y equals what?
Y equals mx plus b.
Good. Mx plus b. Okay. What is m?
M is the slope.
Cool. What is the slope of this tangent line?
It would be 4 times 2 to the third.
Good. Yes. It's the derivative of the function at x equals 2, right? Which is 4 times 2 to the third. Good. So that ends up being 32, okay? So now, I know this is 32, teacup, okay?
Yeah.
What else do I need in my equation, my line?
The
what else do I need?
y-axis.
I need the y-intercept. I need b. Yes. Y equals mx. Noise, chill. Before I start saying it's y equals b0 plus b1x, I'm going to say this is the equation of a line next. Noise. Okay. How do I figure out the intercept?
We could do y to. We don't have 2 coordinates.
We just need one coordinate, right?
Oh
Like-
god, this is statistics.
No. This is statistics, but don't worry about that. So we just need a y coordinate and an x coordinate, right? How can I get the x and y coordinate? And this is the x and y coordinate somewhere on this tangent line. But I know this tangent line has to hit this function at x equals 2, right? So that kind of helps me out. That already tells me, oh, well, I have an x point. I could use 2. But what's the y point there? How do I figure that out, teacup? How do I figure out what the y coordinate is? Teacup.
Well, let's see. We can't just substitute.
Substitute what?
I have no idea.
So you have the x coordinate, right? I know this tangent line and the function both share the point x equals 2. How do I figure out what that y coordinate is? Would it maybe help if I knew what the equation of the function is? Like the blue function?
Yeah.
See how that's here? See how I could maybe figure out what the y coordinate is?
My head hurts.
My head hurts too, dude.
I just got a bag of cough drops next to me.
It's okay.
So we have the y. So we need to figure out when it intersects y at the y-axis.
Yeah, don't worry about that. No. That is eventually how we're going to figure that out. But what we're going to do, when we've done this many times before, right? If I have the slope and a point, right? I plug in the slope, I plug in the point, and then I can solve for b. I can solve for the y-intercept. All I need here is the point. I need a point. I have the slope. I know the slope is 32. I need a point. I know
Yes.
the x-coordinate of the point is 2. How do I figure out what the y-coordinate of this point is? It's not the y-intercept. It's like, what's the y-coordinate of the blue point?
Well, we can't do y2 minus y1 over x2 minus x1.
No, that's finding slope. We don't need slope anymore. We already have slope. Slope is this. You already used this to find the slope. Let's remember teacup. This thing right here is f of x, right?
Yes.
What does f of x do? Like, if I give it an x, what does it give me back?
No answer.
You know what it is. What happens when I give what happens, bro? Come on, dude. I know you know this. I know you're probably sick, but okay. F of x, right? I give this bitch an x. What does she give back?
I physically cannot
Don't
answer.
say that. Come on.
I know. I eventually get frustrated, Hypatia. That's when I start cursing. It gives me a y. It gives me a y.
This was misogyny.
Well, okay,
This
whatever.
was something
All right.
else. This was Sutton or C.
Male slut or something. I don't know. Whatever. Okay. Y. Every time I give it an x, f of x gives me a y. Do you remember this, teacup? Do you remember how a function works? I know you do. You're smarter than this. Teacup.
Cool.
Okay. If I give a function x, what do I get out?
You get y.
Good. Okay.
So I need to get a tissue. So what if we just put x to 4?
Yes. You see how I can plug in 2 here? And that might give me a y coordinate?
Yes. That means we have x to the 4. No, we
Uh-huh.
have 2 to the 4.
2 to the 4, which is what?
2 to the 4. I was about to say 32, but that's not right.
It's not 32.
It's 16, I believe.
Good. 16. Good. Do you see how I can solve for b now?
Yes.
What is it?
And let's see, wait. Now we just gotta do 32 times 2. No, 16. We can't only. We gotta first get that 64. 64 plus b. And then we can't really subtract 16, because that would just be 64 minus 16 plus b. We could do minus b and then minus 16. And then we
No, just minus the 64. Just put the 64 over.
Oh.
You see how this is easier? What's 16 minus 64? What's that?
16 minus 64, 48.
You are right. It's 48. It's minus 48. Minus 48. Okay. So now I have my b. So what's my final equation?
Well, let's see. It was when x equals 2. So y is -4. So y equals 2. Wait. mx plus b. Y equals 2x plus minus 48.
No. What was m? M was the slope, right?
Yeah, and what's the slope? Oh wait.
Slope comes from here.
What was I looking at? 4x to the third.
So what was the slope?
We substituted in for 2. Wasn't it like 32 or something?
32. Good. So it's 32x
32x minus 48.
minus 48. There you go. Good.
Bro, it kicked me right off as soon as I.
Yeah, you're good. What's up, Justin?
What's good?
Chillin'. Chillin'.
Oh my god, I'm dying.
Everyone's dying apparently.
Quite widowy. Is my mic off? Hold on.
It's okay, Teacup. You're not dumb. You're sick. But yeah. I apologize. I get frustrated sometimes. That's why I will start cursing. I know I shouldn't. You're not dumb. I never called you dumb, but you're smarter than this. I know you're much smarter than this. You know how to do this, Teacup. You're incredibly smart. That's why it like frustrates me when you can't get things.
Can we do like you know those variables where you add the variables on the top and then have the exponents stay the same? Like x and then have the power to
What?
15 and the power to fucking 75 and then you add them.
Go find me a
and then you keep the
screenshot.
same.
Justin, go find me a screenshot of what you're talking about,
I
dog.
can't send you a screenshot because my fucking math teacher doesn't do that shit. They don't
What?
do whatever the hell
What,
it is.
you don't do homework?
No, they don't do homework on fucking computers anymore.
Oh, what do they
Like,
do?
literally.
What, can you take a picture with your phone?
Paper.
Yeah, you got a phone, dog. Take a picture.
Here's the thing. I don't keep all my homework.
Dude, I don't get this, man, dude. Your teachers don't give out homework. So, like, how are you learning?
No. We get homework. Well, we get it on paper, and after I'm done with it and show my teacher,
Yeah.
I throw that shit away.
Okay, well, there's your problem. Yeah, don't throw it away, dude. Hold on to it, dude, so I can help you. I can't help you if you're just throwing papers
Let me
away.
show you an example. Hold on.
There you go. Thank you. There you go. Go show me an example. Let me help
What
Noise
the
out real quick.
fuck is that?
Let me help out Noise real quick. Go get me an example. Okay. Let's see. The force diagram shows a charge Q and a minus charge by distance D. The particles exert a force F on each other. An additional charge of 2Q is then given to each particle. Okay. So what? So this thing is now 3Q. And then this thing is now plus Q. And this is increased to 2D. Oh, what is the force that now acts? Oh, I like this. What do you think this one is? This is actually pretty cool. This is a cool one, actually. So here, let's figure out what the force was to begin with. The force that to begin with, that was, that's always KQQ over R squared, right? So that's positive Q times minus Q over R squared, which is D squared, okay? So that's, oh, Jesus. Okay, no, go somewhere else, please. Thank you. Okay. So that becomes negative QQ over D squared, right? That's a negative force, which means they're attractive to each other. All right. Now I have new charges, which is 3Q. And this is now positive Q, because it went from minus Q up to positive Q. And then this is over 2D squared, which is the same thing as 4D squared, right? Do we understand this? 2D squared is going to be equal to 4D squared. Because I got to square the whole thing. So then the question is, how do these two forces compare to each other? Okay. Well, first of all, it's now going to be repulsive, right? Because the force is positive. And you can also see that, right? If this is positive and this is positive, they repel each other. Okay. And then even more so, there's a coefficient in front of this force, right? There's a 3 over 4. So I think it's this. It's a repulsive force of 3/4. That's a pretty good question, Noise. I actually like that one. That's cool. Yeah, that makes sense. Okay, Justin, what's up? And then I want to see Hypatia's solution to this stuff. Justin, what's up? You need this? Or you want to know how to add exponents? Is that what you're doing? How to multiply exponents together? Justin? He's kidding, I
Bro,
swear.
my phone is stuck in it right now.
That's okay. Like, you wonder what this is? Like, x to the third times x to the fifth is? Like,
So that would equal x to the 7. Wait, 5.
no.
8. No,
Eight.
x to the 8.
Yes, x to the 8. Good, yes.
Did
They
you
add.
do my own example and I just forgot?
No, I just made another one for you. Okay, what about this?
Oh.
What would this one be?
7 to the 8th power.
Close. Okay. So, it is going to be x to the 8th power. You do multiply these. You multiply these together. Let me show you why. Okay?
Bro,
Do you-
my teacher must be retarded then.
No, it's okay. You're just misunderstood. Okay. Do you remember that, for instance, if I have like 4 times 3, that's the same thing as 3 times 4? Do you remember this, Justin?
Yeah.
Like, you can move shit around? Okay.
It'd
I'm gonna
be
do...
12 to the 8th power then.
Good.
12x to the 8th
Exactly. So what I'm going to do is I'm going to pull the 3 over here. So this is 4 times 3 times x squared times x to the 6.
Second power times this. Yeah, that. And that would be 12x to the 8th power.
Yes, good. Yes, exactly. Okay, good. All right.
Hold on, I have my packet, one of my other packets. I hate looking through my packets, so annoying.
Oh, wow. See, your teacher does do stuff for you, dude. Your teacher does do stuff for you. You just don't want to get it out. God damn it.
Give me a second, alright?
This is why I need coffee today.
If I could,
Y'all
if I
putting
could
me
take
on
a
tilt
picture
today.
of every page and put into a Google Doc, you'll see how many pages we have, alright?
It's okay. It's okay. Just take a picture of the stuff that doesn't make sense to you, dude. That's what you need to do.
Yeah, but I don't got light in my room, so...
Go turn on a fucking light bulb. What? I don't have
Yeah, I'm
light
too
in my
short- I'm
room?
too short
Does
to
your
go
mom
light
not pay
shit.
for the electricity? Like, what?
I don't have a mop.
Oh, dear. What's up,
Hold
Ethan?
on.
How's the stream going?
It's good. We're getting
Multiply
through it.
exponents. You put them inside of quotation marks. These.
Okay. Oh, okay. All right. So what
I'm
about
gonna
this?
finish
No, I got you. I got you, bro. I got you, bro. Okay. Let's say, for instance, we have x to the third to the 6th. You mean like this? Like what does this become?
Kind of like that, yeah. So like, there's a b, and then to the 5th power, like inside of
Okay.
quotation marks.
Let's do a b
Like that-
a
like-
the third, b second to the 5th.
Like that.
Yeah.
No,
you know how to do
wait.
this?
No, it's only the exponents, whatever the letters are. I forgot what those called.
What? Well, it's like x to the a to the b.
See, I'd show you. Wait, hold on. Wait. Hold on, wait.
It's
wait,
okay.
wait,
Here.
wait.
I already know.
Wait.
I already know what you're doing. So let me just ask you questions and you see if you can do them. Okay.
You say it. I got to take a
Okay,
picture.
got it.
You got a Hypatia?
Yeah, I got it.
Did you send it in
Battery
office hours?
charge.
Can I pull it up?
Let me. Do you
wanna
want me
screen-
to show this?
Yeah,
screen?
you wanna-
I got
yeah,
how
share-
to
yeah, share your-
calculate the valuation.
Yeah, share your screen. Give me a second here, Justin. I want to see what Hypatia's doing real quick, okay?
Let me think. I need to use OBS.
Yeah. You can share your screen with Disc. Oh, good. Well, you use Web Discord though, don't you?
Yeah,
I
no, you
use
can search your
Linux.
screen.
It doesn't really let
You
me
can search
show
your
it.
screen with web.
Yeah.
Let me see. Start virtual camera, and then
We love the virtual camera.
window capture. Yes, that one. Let me
All right,
capture.
I got it. All right.
All right, send me a screenshot, Justin. You're okay. Send me a screenshot, Justin.
I'm in light now, so I can actually take a picture.
I'm glad your dad paid the electricity bill.
No, I'm using my monitor.
I thought you don't have a monitor.
I bought the one. I bought the monitor. Remember?
I'm messing with you, dude. I'm messing with you.
You give me more brain damage than my teacher does.
Why are all you guys sick too? Why are all you guys sick?
I'm not sick. It's allergies.
Okay,
Play my
got
own.
it. Can you see
Thank
it?
you. I can. Let's put it on,
Okay,
dude.
so here, V200, right? Yeah, and it's 200, so 197. and then we want 197 divided by 3 and round down. So
Okay, for
yeah,
the
you
floor.
can do that. B3 297. What's the next one? What's the next factor?
5.
49. So okay, I think it's just 49.
No, it's the answer's 49, dude.
Yeah. Like,
Because that's what putting the 4 does. Putting the 5 in,
What?
sorry. Probably, yeah, putting the 5. Put the 5.
It's in 5, so you have to choose the smallest one, right?
Yes, I agree.
Yeah. So you don't even need to consider 2 or 3. You just consider 5.
Even though it's 2 to the 3rd, because is that going to be 197 divided by 3, which will get you down to like 66? Or 62? Sorry.
Yes, but you have to take the floor of that division because.
Yes.
Yeah, you get it, right?
Oh, okay.
I don't need to. Well, and then you can look at the code, but then.
Yeah. Can you copy paste that code into text, or is it very long, the code you did, or?
Well, the thing is that it doesn't work on your computer. You have to install the environment and then run this thing.
Oh, I see, because it uses a bunch of special packages or something.
It's Haskell. People don't really use Haskell that much, but I love Haskell because especially look at this function.
Yeah.
It's a lazy function that I basically tell it to do the computation on all integers and
Yes.
then take only the ones I need. So
Oh, wow.
this thing, it's a very weird way of programming, but once you get used to it, it's extremely powerful.
Well, so here's my question. Did you solve this whole question with 9 lines of code?
Sorry, 2 lines of code, not 9 lines. Those are irrelevant.
Okay, let me show him a second. Yeah, okay.
It's
well,
actually 1 line, but it's convention.
this is the line of code you basically solved the whole problem with.
8 and 9.
8 and 9. Okay. V is rational, implies integer. Are you basically saying that V has to be a rational integer? Is that what this line of code does?
No, this is a function. It takes a rational and then another rational, so P and N, and then the integer. In fact, if you want, I can do something more with it. For example, with that question, let's just say F, I will. You will give me a integer, and then I give you a integer k, right? So F, you give me the n. I will tell you to. First of all, I need to factorize the n, right? I don't even know how to factorize, but that's.
Damn, this is I love computer science stuff like this. This is cool. Haskell.
Factor? Is that how you factor an integer? Haskell factorize because I'm factors in Haskell. Currently, I only know how to generate. I have to write it myself. That's horrible.
It's okay.
Yeah, I have to write it myself. But yeah, so basically what this V does is that it's going to evaluate the VP of n factorial.
Okay. VP of n factorial. I see.
So with that formula you just show.
Where did you say that n was the factorial though? Where in this code did you say n was factorial?
You don't need to remember, like there is a formula.
Oh,
for that.
yes. I remember. Sorry.
I can show you how this thing works because say, so I do this part, take while, I say v, sorry, I do dot. Wait. How should I do it? Here. Here, I'm going to. So it's going to give me a list of integers. I take the sum away. Okay, so now 3 to 8. So yeah, you can see you are going to add 1, 2, 4 together, right?
Okay. So that gets you 7, right? That's what you did basically?
Yeah, 4 to 1. That's the terms you are going to.
Oh.
Because 8 2, 2, that's just 8. It doesn't even let me. Sorry. Well, I don't need to tell you what a by 2 is.
Yeah, I know it.
A
Yeah,
by 2
it's 4.
is 4, and
Yes.
then a by 2 to the 2 to the second power, that's 2. And a by 2 to the 3, that's
3
1.
powers. Uh-huh.
If you want, we can do something longer, like 200. Yeah, and then yeah, and then if you want, you can see I do some. So basically, I can add that list.
Very cool.
List
I see.
together.
I see.
Uh,
That's
so
super cool,
these
Hypatia.
are the codes. If anybody wants to study it, so you can look at it how that it's done. Yeah.
That's super cool. Do you think ChatGPT could do this? ChatGPT could like turn, for instance, some sort of mathematical expression and then just write Haskell code for it?
Let's try it. Show me, show me on the screen that the thing, that formula, the summation.
Yeah, here's sure. It's this one.
Okay, I'm going to take a screenshot. Here.
Although it says it's a floor function, so it may not be able to do the floor function thing.
It's able to.
Okay.
Let's see. I will tell ChatGPT to try to do the program as I did it.
Okay.
So here I'm going to use another AI tool to transform this entire thing into LaTeX. Come on.
I could have probably given you the
This one. Okay, now it's giving me the that. And then I'm going to go to ChatGPT. Write the following formula in class. And then I'm going to say yes. Oh shit! It's I think it's giving a correct answer or not, but it's writing it in a very horrible
complex way.
In fact,
Yeah.
In fact, actually, it's not giving me the correct answer. It's nonsense. It's hallucination.
It's nonsense. It's a hallucination. I love that.
This is telling me factorial new p np if n is less than p, you give it a 0. Okay. Otherwise, n divided by p plus new p n divided by p.
It's a lot.
I think this one, it doesn't work because this one is an actual infinite computation.
Yeah, it's not stopping at 0.
It can be modified for it to work, but it's not elegant. This is elegant.
Yeah, no, I like your code. Your code is like 2 lines, dude. That's really cool. This is awesome.
Yeah, well, anyways, I hope this solved your question.
No, it did. No, and that's a unique answer. I don't think anyone got that. I think Jamarcus originally said 197, right? That was the 2 answer. And then I think Noise originally said like 65. But that wasn't, I guess, the right answer.
You gotta take the lowest one.
The lowest one.
Because
yeah.
The exponent, it only has so many factors of 5, much less than the other ones. So
Sure.
you have to take the lowest one, right?
Yes.
Okay.
Very cool.
Well,
Awesome. I appreciate that, Hypatia. I really do. I appreciate that.
I will still put this code into
Yeah,
Office
Yeah, put it there. I'd love to maybe like try messing with it or something. I'm sure there's an online Haskell editor or something I can do stuff with.
Not, you can try, but I mean,
I'll try and find one.
Yeah, here. Oh yeah, it even has syntax highlighting.
Yes. Yeah. No. It's yeah. Super cool. I like that. That's very cool. Thanks, Hypatia. I appreciate that.
Anything else? I mean,
I think that's good. I'll tell Kiss Killer to at you in the Discord if they have any other questions about like math stuff. It seems like Kiss Killer wants to learn math for the objective of I guess tackling
What about me, bro?
computer science problems like algorithms. Don't worry, I'm gonna get to you, Justin. I got you, Justin. Give me a second. But yeah, that's what I think Kiss Killer said. It says Kiss Killer said they want to learn calculus, linear algebra, concrete math with the end goal of tackling computer science topics such as algorithms. So I said that's a lot of linear algebra, right? A lot of computer science is linear algebra.
I mean, sure. Like, do you enjoy the coding with Haskell or Python? I mean, I hate Python because they take this non-opinionatedness
Yeah.
to a extreme, so that nobody has any consistent. Like, I like Haskell because it's consistent. Yes, it's the essence of functional programming. It's the holy grail of functional programming because there are abstractions that works.
I see. Yeah, I guess that's the problem with things trying to be like too like decentralized and too open source, right? Is that you don't really get
Not really,
convention.
I mean, Haskell also has a governance. Like Haskell also has a parliament, let's say, but
Sure.
it doesn't. The Constitution is not written to include every paradigm. Like paradigm,
Okay.
we discriminate one to another because they are literally mathematical facts. There are opinions that are good. There are opinions that are bad.
I get it. Yes. I mean, there's some objective truths to things. Yes. Nice.
Yeah, well, that's like it's like mathematical concepts. Like, yeah, don't do like you.
They
can't
said
really...
they said Haskell changes how you think. Yeah, I think that'd be pretty cool.
Yeah, Haskell does change how you would think. It's any functional programming language, especially the ones that force you to be purely functional. It changes how you think.
That's super cool. Nice. Hey, Justin, here. Let me help you real quick with exponents, and then let me end the stream out. I'm getting kind of tired. We're almost at 2 hours.
What
Justin.
is goody McGiddy?
What's good? All right, how do we do this? Justin? Do you know how to do this?
No, I have brain damage.
Okay, let's help you with the brain damage. All right, if, for instance, I had this. If you have x to the a to the b, you multiply these exponents together. This is the same thing as x to the a times b, is what we say. So, Justin.
Alright, so,
Yeah? Did you get that? Do you mean to do that again?
so X, A, and then... I'm pretty sure it's supposed to be 2 letters inside the same one.
Yeah, I'm gonna get to that. I want to make sure you understand the basics first, and then I'll test you on your quiz questions. Okay. If I have
Alright, well, it's
3,
not-
well, whatever. If I have 3 to the second to the fourth, what would this end up being?
You have 3, wait, hold on.
What was the rule back here?
36. It'd be 36.
Why is it 36?
Because 3 times 2 is 9, 9 times
Oh,
4 is 36.
Well, it's not 9 times 4. You're right that this is 9, right? But then this is 9 to the fourth. This is not 9 times 4.
Oh, 9 times 9 times 9.
Yes. The other way to write this, Justin, is to say that this is 3 to the 8th. Do you see how you multiply these two together?
Yeah.
Are you playing Fortnite?
No, actually, I'm playing a game called Grounded.
Okay, well, here. Stop playing the game real quick so I can teach you.
Alright.
Okay, thank you. All right. Look, okay, so anytime you have an exponent to an exponent, Justin, right, you multiply the exponents together, okay? So this is 3 to the 2 times 4, which is the same thing as 3 to the 8th. Okay?
Okay.
All right. Let's say, for instance, I have 3a all to the second. What is that going to be?
9A.
Close. You're going to distribute this 2 onto both of these. This becomes 3 to the second, a to the second, which is what?
Oh. Which is 9 to the second, A.
No, it's just
To the
9, a to the
Oh,
second.
9.
Because 3 squared is just
9A.
9. Okay. Let's say we have this. Let's say we have 5 a to the third, b to the second, all to the second. What is that going to be?
So, frick.
You got it.
So hold on, it'd be 5 to the third power.
No, not to the third.
So hold on, we gotta separate it. All right. So I'm
Yeah.
pretty sure it's 5 times 5 times 5, if I'm correct, right?
No. This is 5 times a to the third times b squared. All of this to the second. You end up distributing the exponent is what happens.
So okay, so it'd be 25.
Good. 5 squared, which is 25, yeah. And then what else? What happens when I have an exponent to an exponent, Justin? What happened back here?
Oh, wait. Addition.
That's not addition.
I meant
Look,
multiplication. I don't even know. My brain hurts.
I know. My brain hurts
Wait.
too.
Okay, so 2 times 3, which would be 6, and then 2 times 2, which would be 4, which means 5 to... So 5 to the second... Wait. 5 to the second power, a to the 6th power, and b to the 4th power.
Wow, good job, dude. Yes. Nice.
My brain hurts.
All right.
I'm trying to send a message to one of my friends, so...
You're good, Justin. What is he? Are you Popular Bananas now, dude? Why do you keep changing your name so many times, dog?
Actually, I'm redacted dot now. If you check my on what is it? If you check my on Discord, it's redacted .9.
That's cool. Okay. All right. Cool. All right. Thank you, everyone, for coming to office hours today. Appreciate learning with all you guys. Our next stream will be on Wednesday. That's going to be an hour later. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. One sec. I need to move something over. Where did my mouse go? Come back here, mouse. Okay, there we go. All right. Yes. So yeah, our next stream will be on Wednesday. I do have some time. I'll play some Fortnite with you guys if you guys want to play. So that's what we do here. I help you guys out with math and science, and then play video games with you guys. Big special thanks to Hypatia. I really appreciate Hypatia going through and showing us all how that Haskell coding works. That was really cool. Those are some new skills that you guys really should learn. Coding is very important, and I'm always here to help you guys with that and maybe get some inspiration and stuff. Hypatia is a goat. Yeah, Hypatia is very smart. Yeah. If you ever have any high-level math questions or you want to be a mathematician, please talk to Hypatia. Hypatia is great. And Hypatia's, is generous enough to donate their time to help you guys out. So, take advantage of that, but respect their time and stuff.
Wait, what? I'm a goat? What?
A goat. Goat stands for greatest of all time. GOAT.
It's an animal, right?
It is an animal. A goat is an animal. Yes. But they're saying you're the greatest of all time.
Oh, okay. Thank you.
Yeah, you're welcome. Yeah, Hypatia's new to the United States, so we have to sometimes explain some of the things, which is okay. Totally okay. Anyways, if you guys want to come play Fortnite with us, I'm going to do it on Actual Gaming, which is our other sister stream. If you're here in the Discord, I'll be in Recess, which is slightly down a little bit. If you're here on the Twitch, just stay on in, and it's going to raid you into our next thing here. So, have a great rest of your Monday. If you want to come play Fortnite, I'll do that with you guys for an hour. And then our next stream will be on Wednesday. So if you got any homework questions, save them. Bring them to us on Wednesday. Let's go over them. Love to teach you guys. And I'll see you guys around. Peace.